Right triangle trigonometry. Pythagorean theorem. If a right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. A squared plus b squared equals c squared. Distance formula. Suppose that you have a point P, x1, y1, and R, x2, y2 are 2 points in the coordinate plane. The distance between P and R, written d parentheses P, R, is given by the formula d parentheses P, R equals, the distance is equal to the square root of x2 minus x1 quantity squared plus quantity y2 minus y1 squared. That is, the distance between 2 points in a coordinate plane is the square root of the sum of the squares of the difference of the x-coordinate and the square of the difference of their y-coordinate. The 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent. Here we have a triangle. Note that we're talking about angle theta. And across from angle theta, or opposite to angle theta, is side A, which is the length of the side opposite the theta. B is considered adjacent. So the length of the side adjacent to theta is side B. And note that the length of the hypotenuse is C, which is across from angle C. It's very important to note how the triangle is labeled. Notice angle A is across from side A, angle B is across from side B, and angle C, which is the right angle, is across from side C, which is the hypotenuse. So sine of theta is equal to the length of the side opposite to angle theta over the length of hypotenuse. Notice a way to remember that is this abbreviation called SOHCAHTOA. So SOHCA is for sine, which is opposite over hypotenuse. Cosine is equal to the length of the side adjacent to angle theta over or divided by the length of the hypotenuse. So that is going to be adjacent over hypotenuse, and we call that SOHCA. And then TOA is the length of opposite of angle theta over the length of side of angle theta, so that's tangent. So that's where we get this acronym called SOHCAHTOA. Another way to remember is some old hogs came around here and took our apple. So note that sine and cosecant are basically reciprocal of one another. Cosine and secant are reciprocal of one another, and tangent and cotangent are reciprocal of one another. So in this first example, notice that I already have the triangle labeled. So we are doing everything in terms of theta. So what is opposite to theta? Well, you're just going to go straight opposite to that angle, and you see that that length is 8. So 8 is considered opposite. So that's the side opposite of theta. And 15 is considered adjacent to angle theta. So we're talking about, I want to make sure you understand, we're talking about theta. And the hypotenuse here is 17. So we have, remember we're doing SOHCAHTOA. So sine of theta is opposite, which is the length of 8, over hypotenuse, which is 15. Cosine of theta is adjacent over hypotenuse. So adjacent to theta is 15. My hypotenuse is 17. And tan of theta, opposite to angle theta, is 8. And my adjacent to angle theta is 15. So my ratio would be 8 over 15. Example 2. Find the exact value or expression for sine of A, cosine of A, and tangent of A. Once again, here we're using angle A. So right here's angle A. So in reference to angle A, 21 is considered opposite. 20 is adjacent to angle A. And 29 is the hypotenuse because it's across from or opposite to the right angle. So we have sine of A, opposite over hypotenuse. So that's 21 over hypotenuse, which is 29. Cosine of A is adjacent, which is side length of 20, over hypotenuse, which is 29. And then tangent of A is opposite over adjacent, so opposite is 21 over 20. So notice on example 3, I do not have the right triangle. So we're going to first create the right triangle. So I'm going to let this be my right triangle, so I'm going to label that C. So opposite to angle C will be side C, so we don't know what C is yet. We'll figure that out in a second. I'm going to label angle A right here. Opposite to angle A is side A, which is given to be the length of 3. And we'll label this B. It does not matter where you label A or B. Opposite to side B is the length of B, which is equal to 4. So now to find C, we know that A squared plus B squared equals C squared. So we have 3 squared plus 4 squared equals C squared. 3 squared is 9, 4 squared is 16 equals C squared. 9 plus 16 is 25 equals C squared. And then we're going to take the square root of both sides. Now, I do want to point out that because this is a triangle and we're talking about a triangle, C is only equal to 5. But normally when we take the square root of both sides, it's plus or minus 5, and then you have to decide on a sign. But in this case, it has to be positive because it's a triangle. So now we're looking in terms of sine of B. So we are using angle B. So everything has to be in relationship to angle B. So we know that opposite of angle B is side B. So side B is my opposite. And adjacent to side B is side A, which is adjacent. And then our hypotenuse is C. So sine of B is equal to opposite over hypotenuse. So it's 4 over 5. Cosine of B is adjacent, which is 3 over hypotenuse, which is 5. And tangent of B is opposite of B, which is 4 over adjacent, which is 3. So one way to remember the reciprocals of sine, cosine, and tangent is, one thing I can kind of point out is you can think of S and C always go together, and C and S always go together. So that way you can kind of remember that it has to be opposite letters, so you kind of think about it that way. So sine of B is 4/5, so cosecant of B is a reciprocal of that, so it would be just flip it, so it's 5/4. Cosine of B is 3/5, so the reciprocal of 3/5 is secant of B is equal to 5/3. Tan of B is 4/3, so cotangent of B is 3/4. Example 4, we're going to find the 6 trig functions for angle A. So we're going to start with the triangle. So we have a triangle. Suppose we have an ABC triangle. And I'm going to label A down here. So the opposite of angle A is side A. Opposite of angle B is side B. And opposite to angle C is side C. Notice that you can label angle A and B flip-flop, but then you have to basically coordinate the sides with it. So here we're given that A is 6. So side A is 6. Side C is 7. So we have to find B. So we know A squared plus B squared equals C squared. So 6 squared plus B squared equals 7 squared. 36 plus B squared equals 49. Subtract 36 from both sides. So B squared equals 13. And then take the square root on both sides. So B equals square root of 13. Okay, so we're doing everything in relationship to angle A. So opposite to angle A is side A. Adjacent to angle A is side B. And we're following the SOHCAHTOA. So sine is opposite over hypotenuse. So it's opposite of angle A is 6. My hypotenuse is 7. So since sine of A is 6/7, cosecant of A is a reciprocal of it. So it's 7 over 6. Cosine of A is adjacent over hypotenuse. So adjacent to angle A is side B, which is square root of 13, over my hypotenuse, which is 7. So secant of A is the reciprocal of that, which is 7 over square root of 13. We do need to rationalize that. So to rationalize, we multiply the numerator and the denominator by whatever root is there, which is in this case square root of 13. So this will give me 7 square root of 13 over square root of 13 times square root of 13 is square root of 169, which is 13. So that's the goal. You want to come back to a whole number without a radical in the denominator. And the reason why we multiply by itself, which is square root of 13 times square root of 13, is so that you get back 13. Tan of A is equal to opposite over adjacent. So that's going to be 6 over square root of 13. And before we rationalize that, I'm going to go ahead and do cotangent of A, which is a reciprocal of that, which is square root of 13 over 6. Now we're going to rationalize tangent of A by multiplying by square root of 13. The same concept applies. This is going to be 6 square root of 13 over square root of 13 times square root of 13 is square root of 169, which is back to 13. That was the goal. Function value for some special angle. We start with an equilateral triangle. A triangle with all sides of equal length and all the angles measure 60 degrees. For convenience, we choose the length of each side to be 2. Okay, so notice that I have the angle, all the angles to be 60 degrees and the length of it all being 2, so that makes it an equilateral triangle. If we are bisecting one of the angles of this equilateral triangle, this will lead us to 2 right triangles, each which will have a 30, 60, 90 degree angles. An angle bisector of an equilateral triangle also bisects the opposite side. Therefore, the shorter length has a length value of 1. So let x represent the length of the longer side. So if x represents the length of the hypotenuse, then we can find its value using the Pythagorean theorem. So in other words, we took the bisect and we had 1 and 1, and to find square root of 2, remember it's like the concept of a squared plus b squared equals c squared. we knew that one of the length was 1. We didn't know b squared. We knew the hypotenuse was 2. So that's 2 squared. So we have 1 plus b squared equals 4. If we take 1 away from both sides, we have b squared equals 3. And then we have square root of b squared is b, square root of 3 is square root of 3. So that's where the square root of 3 comes into play. So if we summarize the 30, 60, basically 90 right triangle, the side opposite to angle 30 has a length of 1. Very important to memorize this triangle. So notice that if the angle is 30 degrees, the opposite to that is going to be the length of 1. That is for 30 degrees. For the hypotenuse, notice is 2. And the side opposite to angle 60 is always going to be square root of 3. We can find the values of trig functions for 45, 45, 90 triangle as well. This triangle is an isosceles triangle. So once again, if we let the lengths be 1, then we have a squared plus b squared equals c squared. So if both of the side length is 1, then we have 1 squared is 1 plus 1 squared is 1 equals c squared. So 2 equals c squared. And when I take the square root of both sides, we get c equals square root of 2. That's where the length of square root of 2 is coming from for the hypotenuse. So in this case, across from 45 degrees always will be the length of 1 on both of the sides, and the hypotenuse will be square root of 2. For special angles using these two triangles, very important, we're using the two triangles. Remember, 30 degrees is equivalent to pi over 6. Remember, pi is 180, so 180 over 6 is 30. For 45 degrees, that's going to be 180 over 4, which is 45 degrees. And 60 degrees is equal to pi over 3 because pi is 180 divided by 3 is 60. So all we're doing is using the two triangles to come up with this chart. And once again, we can do the 45 since I have the triangle here first. So sine of 45 degrees is going to be opposite, which is 1 over square root of 2. And then to rationalize that, we multiply by square root of 2, and we get square root of 2 over 2. Cosine of 45 degrees is also 1 over square root of 2. Multiplying by square root of 2 over square root of 2, we get square root of 2 over square root of 4, which is 2. So once again, that's also square root of 2 over 2. And then tangent of theta is equal to opposite over adjacent, which is basically 1 over 1, and that gives me 1. And then using the previous triangle from the previous page to do 30 degrees and 60 degrees. So once again, for the 30 degree, 60 degrees, we are using the triangle. That it doesn't matter how you label it, but the idea is if opposite to 30 degrees is 1, the length of 1. Opposite to 60 degrees is the length of square root of 3, and opposite to the right angle is 2. So that's the idea of how they got the 30 degree angle and the 60 degree angle for sine, cosine, and tangent. So for example, I want to do cosine of 60 degrees. You draw the same triangle that I just drew. Does not matter where you have your 30 and 60 labeled, okay? So if I do 30 right here, it's fine. If I do 30 on the top, it's fine. It does not matter. So let's say I want to do it up here. But I do need to keep in mind that opposite to that is the length of 1. If I do 60 right here, opposite to 60 is the length of square root of 3. And here my hypotenuse is 2. So cosine of 60, I'm using 60. Cosine is adjacent over hypotenuse. So adjacent of 60 is the length of 1. This would be considered adjacent. And hypotenuse is 2. So cosine of 60 degrees is 1 over 2. Notice we could have used the chart and to verify. That's how this chart is written, with using the triangles. Example 6. For each expression, give the exact value of secant of 30. So we're going to start with our triangle. And I'm going to label 30 on the bottom. So remember, opposite to 30 is 1. I'm going to label 60 degrees right here. And opposite to 60 degrees is square root of 3. And my right angle is 90 degrees, and opposite to my right angle is the length of 2. Notice that example 5 and 6, I drew the triangle a little differently, but keeping in mind that the length across from 30 degrees is 1, and so forth. So secant of 30 degrees is equal to, remember, the reciprocal of secant is cosine. So remember, the reciprocal of secant is cosine. So for cosine, we use TOA, so adjacent over hypotenuse. So we're looking at 30 degrees. And if I'm doing cosine of 30 degrees, it's going to be adjacent, which is square root of 3, over hypotenuse, which is 2. So therefore, secant of 30 degrees is going to be the reciprocal of that. So that's going to be 2 over square root of 3. And when we rationalize that by multiplying by square root of 3 over square root of 3, we get 2 square root of 3. Square root of 3 times square root of 3 is square root of 9, which is 3. Example 7, we're going to find the exact value of tan of 45. So this time I'm drawing the 45, 45, 90 triangle. So remember, the length of 45 degrees opposite to the both of those is 1. And opposite to our right angle is square root of 2. The length of the hypotenuse is square root of 2. And here we have tangent. Remember, tangent is, once again, remember, TOA. So tangent is opposite over adjacent. Pick one of the 45-degree angle. Opposite to 45 degrees is the length of 1. And adjacent is 1. So tan of 45 degrees is equal to 1. Example 8, we're finding the cosecant of 45 degrees. Once again, for the 45 degrees, the length associated with the 45 degrees is 1, and the length associated with the right angle is square root of 2. So cosecant is a reciprocal of sine. So we know sine of 45 is opposite, which is 1 over hypotenuse, which is square root of 2. Therefore, cosecant of 45 is going to be the reciprocal, which will be square root of 2 over 1, or simply just square root of 2. The reciprocal identity holds for any angle theta that does not lead to zero denominator. The reciprocal identities for angle theta for which the functions are defined following the identity holds. Sine of theta is equal to 1 over cosecant of theta. Cosecant of theta is 1 over sine of theta. So if you know sine, you know cosecant. If you know cosecant, you know sine. Cosine of theta is 1 over secant. Secant of theta is 1 over cosine. Same thing. If you know cosine, you know secant. And if you know secant, you know cosine, because you're just the reciprocal or the flip of them. Tangent of theta is 1 over cotangent of theta, and cotangent of theta is equal to 1 over tan of theta. Quotient identity for all angle theta for which the denominator are not non-zero, the following identity holds. Sine of theta over cosine of theta is tan of theta, and cosine of theta over sine of theta is cotangent of theta. You do need to remember that reciprocal identity is 1 over the function, and then quotient identity is basically two functions over each other. Pythagorean identity for all angle theta for which the function values are defined. The following holds: sine squared plus cosine squared equals 1. So you can always use these Pythagorean identities to come up with the other function. So in other words, if you know sine, you can figure out cosine by solving. Tan squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. You do need to memorize these three identities. Example 9. Given the sine of theta is 2/3 and cosine of theta is square root of 5/3, find the value of each of the four remaining trig functions. So here, I wanted us to use sine of theta over cosine of theta to give me tangent of theta. So we're going to start this problem. We know that sine of theta is 2/3 divided by cosine of theta, which is square root of 5/3, and that will give me tan of theta. So notice here that the 3's will cancel out, giving me 2 over square root of 5 is equal to tan of theta. And since I know, before I rationalize it, since I know tan of theta, I know cotangent of theta. Cotangent of theta is equal to the reciprocal. So cotangent of theta is equal to square root of 5/2. So tan of theta here, I'm going to rationalize 2 over square root of 5 by multiplying by square root of 5. So we have 2 square root of 5. Square root of 5 times square root of 5 is square root of 25, and square root of 25 is back to 5. And since we know sine of theta is 2/3, the reciprocal of sine of theta is cosecant of theta, which is 3/2. We're just flipping it. And since we know cosine of theta is square root of 5/3, we know secant of theta, the reciprocal of square root of 5/3, is 3 over square root of 5. Once again, rationalizing that by multiplying by square root of 5. So we have 3 square root of 5/5. Example 10. Given that sine of theta is 1/2 and theta is an acute angle, find the value of cosine of theta using the trig identity. So all we're here is we're looking for cosine of theta. So the way sine and cosine is related is by sine squared theta plus cosine squared theta equals 1. So that would be the only way we can find cosine of theta, is with this relationship that we have so far. So I'm going to substitute 1/2 for sine, so it's 1/2 squared plus cosine squared theta equals 1. So 1 squared is 1, 2 squared is 4, plus cosine squared theta equals 1. We're going to subtract 1/4 from both sides. So we have cosine squared theta equals 1 minus 1/4. You can hit it in the calculator and hit 1 minus 1/4 and then hit the math fraction button, or you can get a common denominator. So 1 is equivalent to 4/4. So 4/4 minus 1/4 is 3/4. And then we're going to take the square root of both sides. Remember, when we take the square root of both sides, it's plus or minus. So cosine of theta is equal to plus or minus square root of 3. Square root of 4 is 2. So in this problem says that theta is an acute angle. And since it's an acute angle, cosine has to be positive square root of 3/2. Okay, only reason why it's positive is because it said the word acute angle. Trig functions and complements. Two positive angles are a complement if their sum is 90 degrees or pi/2. Any pair of trig function f and g for which f theta is equal to g parentheses 90 degrees minus theta and g theta equals f 90 degrees minus theta are called cofunctions of each other. So notice that if this is 90 degrees And if we let this angle be theta, then the way you would find the other angle is it would be 90 minus theta. So the values of trig function of theta is equal to the cofunction of the complement of theta. So cofunctions or complementary angles are equal. So sine of theta is equal to cosine of 90 minus theta. Tan of theta is equal to cotangent of 90 minus theta. And secant is equal to cosecant of 90 minus theta. And you can always replace 90 degrees with pi over 2. So in example 11, we want to find the cofunction of 42 degrees. So cosine of 42 degrees is equal to sine of 90 degrees minus 42. So cosine of 42 degrees is equal to sine of 48 degrees. Example 12, we're finding the cofunction of sine of 60. So we have sine of 60 degrees is equal to cosine of 90 minus 60 degrees. So sine of 60 degrees is equal to cosine of 30 degrees. And to be quite honest, let's check that and let's verify. So remember that this is the 30, 60, 90 triangle. So opposite to 30 degrees is the length of 1. Opposite to 60 degrees is the length of square root of 3. And opposite to my right angle, which is 90, is the length of 2. So if we remember, sine is so opposite over hypotenuse. So opposite over hypotenuse of 60 degrees. So opposite of 60 degrees is square root of 3. Hypotenuse is 2. So if we do cosine of 30 degrees, so cosine of 30 degrees is equal to adjacent, which is square root of 3. So adjacent to 30 degrees is square root of 3, and hypotenuse is 2. So notice both is equivalent, and that's why we did this problem correctly. Now, you can also use the calculator, but sometimes it doesn't give you the exact value, so that's why you still have to go back to the triangles. But to evaluate trig functions, we can use the keys on the calculator that are marked sine, cosine, and tangent. And be sure to set the mode to degree or radians depending on the function you're evaluating. Now, to find its reciprocal function, you would just say 1 divided by whatever answer you get. So for number 13, we're doing sine of 72.8 degrees. Well, first of all, make sure you're in degree mode. So go to mode. And then make sure that it's on degrees. So then we're going to type in sine, and then just type in 72.8. Close the parentheses, hit enter, and we should get 4 decimal places would be 0.955. Since it's 27 and we're doing 4 decimal places, notice this is more than 5, so we're going to round to 0.9553. Example 14, we're doing cosecant of 1.5. So notice this is in radian modes because it doesn't have the degree symbol. So once again, we're going to go to mode and change it to radian. So for cosecant, remember cosecant of 1.5, that is the same thing as 1 over sine of 1.5. So we're going to type in 1 divided by sine of 1.5. And we get 1.0025. Application. In application of right triangle, the angle of elevation from point X to point Y above X is an acute formed by XY in a horizontal ray with an endpoint as X. And basically, if you're looking up, it's an angle of elevation. If you're looking down, it's an angle of depression. So the angle of depression from point X to Y below X is the acute angle formed by the ray XY and a horizontal ray with the endpoint X. So we have a shadow of a vertical tower that's 40.6 centimeters long when the angle of elevation of the sun is 34.6. We want to find the height of the tower. So here's my building. And it casts a shadow of 40.6 meters. And right here's the sun. And the angle of elevation is 34.6. And we want to find the height of the tower. So to find the height of the tower, we know that our angle, and we know 40.6. So in relationship to the height, this is opposite over adjacent. And what trig function gives us opposite over adjacent would be tangent. So we have that tan of 34.6 degrees is equal to opposite, which is the height, over adjacent, which is 40.6. And to solve this, we're going to multiply both sides by 40.6. So the height is equal to, we're going to hit 40, make sure we're in degree modes. So we have 40.6 tangent of 34.6. Hit enter and we get 28 meters. Example 16, we're going to find the angle of depression from a top of a 97 feet building to the base of the building across the street, located 42 feet away. Okay, so we'll start with the first building. That's 97 feet. And we have another building across the street, which is 42 feet away. And what we want to find is the angle of depression. So we're on top of this building. And I'm looking for this angle right here, which is the angle of depression. So in order to find that angle, first we're going to find this angle right here, and I'll just call it B right here. So in relationship to B, 97 is opposite and 42 is adjacent. So I can use tangent again. So tangent of B is equal to 97 over 42. And then we're going to use the inverse sign of both sides to solve for B. So B is equal to, so tan inverse and tan kind of cancel each other out. So when we hit tan inverse, we're going to hit second tan, and you get the inverse symbol, and hit 97 divided by 42, and that will tell me the angle, which is about 67 degrees. So we know B is 67 degrees. So we know our angle of depression, which is right here, and angle B are alternative interior angles, and hence our angle of depression is also 67 degrees.